This is the 8.3 video on division properties of exponents. We'll start our properties off with the quotient of powers property. Again, similar when we're talking about the power of a powers property, it's important to note that in our problem we need to make sure that we have variables or coefficients that have the same base. So when I look at my first example, x to the power of 5 over x squared, I can write this out as x, let's start over there. I can write this as x times x times x times x times x 5 times, divided by x times x. Now, way back when you learned about common factors, maybe in 4th grade, your teacher would let you cross off common factors. So you can see I have two factors that are the same in the numerator and the denominator. I can no longer cross factors off because I'm out of factors in the denominator. I'm left with x times x times x, which will give me x cubed. Now hopefully, because we've been always looking for patterns with our rules, you'll see the original problem, x to the power of 5 divided by x to the power of 2 will give me x to the power of 3. And to do that, to get my shortcut without having to write my work out the long way, I hope you notice that I can subtract my exponents. Hope you'll trust me in this next example when I have x to the power of 9 divided by x to the power of 15. When I subtract my exponents, I'm going to get 9 to the power of negative 5. In our last video in section 8.3, we said that you cannot have any answers with a negative exponent. So we'll have to simplify our negative exponents by taking the reciprocal. So we'll simplify this by 1 over 9 to the power of 5. That is a simplified answer. Okay, here's another example of the quotient of powers property that also brings in the product of powers property. So you'll see in the numerator I have the same base, 6 to the power of 7 times 6 to the power of 12. I can simplify that by writing that as 6 to the power of 19. So when I multiply with the same base, I add my exponents. So I have 6 to the power of 19 divided by 6 to the power of 10. I need to simplify that, and to do that with the quotient of powers property, I subtract my exponents. So I'll get 6 to the power of 9. All right, the next property is the power of a quotient property. This property is very similar to the power of a power property, where anything inside the parentheses needs to be raised to the power that's outside of the parentheses. So in my first example, I would write this as a to the power of m over c to the power of m. In my next example, I have to raise everything inside the parentheses to the power of negative 3. So I have 5 to the power of negative 3 over 4 to the power of negative 3. So you should remember in section 8.2, anything raised to a negative exponent needs to be simplified. To do this, I need to take the reciprocal of both my numerator and the denominator. When I do this, I will get 4 to the power of 3 in my numerator and 5 to the power of 3 in my denominator. This will simplify to be 64 over 125. Here's another example of the quotient of powers property. I need to simplify my c, the d, and the e's. I look at this as 3 separate things. So I'll start with my c's. So c to the power of 10 divided by c to the power of 12. That's going to give me c when I subtract my exponents to the power of negative 2. I'm going to move on to my d's now. I have d to the power of 6 divided by d to the power of 4. When I divide, I subtract my exponents. That's going to give me d to the power of positive 2. Lastly, I'm going to look at my e's. I have e divided by e to the power of 7. Remember, if I don't have an exponent, I'm going to assume it's 1. So e to the power of 1 minus e to the power of 7, or divided by the power of 7, is going to give me e to the power of negative 6. Okay, again, anything that has a negative exponent, I need to take the reciprocal of it. So it looks like I need to take the reciprocal of c and e. This will leave me with d squared all over c squared times e to the power of 6. That is my final answer. All right, moving on. To make some problems a little bit more complicated and mesh all the multiplication and division properties together, you'll see problems that look like this. Now in this problem, we need to think about our order of operations. So anything that's being raised from parentheses to an exponent, we're going to want to do first. So we're going to want to simplify this first. So this is a power of a power, so we have to distribute that 3, the exponent of 3. So I have 4 cubed times x squared cubed. When I'm doing a power of a power, I multiply my exponents times 2 times y to the 4th. I like to keep my things separate here. It helps me when I need to simplify. All over 6 times x squared times y to the 10th. All right, so what I need to do next now is I'm going to simplify what I've got. So in my numerator, I know that I can take 4 cubed times 2. 4 cubed is 64 times 2. That should give me 128. And then I'll have x to the 6th, y to the 4th. In the denominator, there is nothing to simplify, so I'm just going to rewrite that. Now I need to simplify my final answer here. 128 and 6 have a common factor of 2. So I'm going to take a 2 out, and I'm going to get 64 over 3. And then I need to simplify my x and my y's. So x to the power of 6 divided by x to the power of 2 is going to give me x to the positive exponent of 4. So I can put that right in the numerator. I have y to the power of 4 divided by y to the power of 10. When I divide that, I subtract my exponents. I get y to the power of negative 6. When I take the reciprocal of y to the power of negative 6, I know that my y to the power of 6 is going to end up in the denominator. Section 8.3 really goes through and really makes a lot of connections with sections 8.1 and 8.2. If you have any questions, please ask a classmate or talk to your teacher in class. And remember, take each one of these problems, the bigger they get, one step at a time, and always relate it back to a simple, much more simple version of the problem.